Welcome to part 2 of this week's lab. We're going to be doing a qualitative analysis of biological molecules. Again, in this week's lab, you're going to be looking at 3 of the 4 biological molecules that you should be learning about in lecture. So in this week's lab, you're going to be looking at carbohydrates, lipids, and proteins. The carbohydrate you're going to analyze is starch. The lipid is going to be vegetable oil, and the protein is going to be egg albumin, which comes from egg whites. You're also going to be looking at a vitamin. So in this case, it's vitamin C. So you're going to look at these 4 molecules. Again, carbohydrate, protein, lipid, and a vitamin. And then you're going to use water as a control. So you're going to have 5 test tubes that you set up. So when you come to lab, you're going to have several things on your bench top. So you're going to see a test tube rack with some glass test tubes in it. You're going to see some pipettes of various different types, and you're going to have a microcentrifuge tube rack, and you're going to have some microcentrifuge tubes. It may be as chaotic as this, or maybe it's a little more organized, but ultimately that's what you're going to see. So I'm going to guide you through what you need to be working with. So first of all, you're going to need your microcentrifuge tube rack. You're going to need these transfer pipettes. So again, they're going to be in these white containers, and they're going to need the microcentrifuge tubes for this qualitative analysis part. You are not going to use this just yet. This is for the quantitative analysis. So just leave that set aside for now and focus on getting together with your partner to get this microcentrifuge tube rack. You're going to put 5 tubes in it right across the second row. So you have the first row is probably already going to be labeled. If it's not labeled, get some tape or ask your instructor for tape and label right across through there. You'll notice it should have a certain labeling scheme to it. Should be water, protein, starch, lipids, and vitamin C. Again, your handout shows that nicely in that figure right there. So it's going to tell you to label things that way. Again, they're probably already labeled. But right there in that row number 2, you're going to put your 5 microcentrifuge tubes. And then from there, what you need to do is you need to get your 5 molecules you're going to look at. Again, water, protein, starch, lipids, and vitamin C. So you're going to find that on one of the side benches, depending on which lab you're in and which instructor you have. It might be set up a little bit different, but ultimately they will be set up something like this. So you're going to have your water, protein, starch, lipid, and vitamin C. So let me go back over here and get my microcentrifuge tube rack here. And what I want to do is I want to transfer 1.5 mils of each of these molecules into my tube. So I need to get 1.5 mils of water into this tube that says water, 1.5 mils of protein into that one, 1.5 mils into that third tube, and so on and so forth. So to do this, I'm going to use the transfer pipette. So this is a transfer pipette, and I want to use the one that says water on it. We don't want to get these mixed up, because if you even get just a drop of the wrong thing in there, it's going to mess up your results. So we want to use the transfer pipette that says water to get our water. So anytime you use any type of pipette, the first thing you want to do is make sure you have a good solid grip on it. Make sure that it's seated or situated properly. In this case, we're going to hold it firm like this. What I like to do is I like to wrap 2 fingers around it like that, and then I'll use these 2 fingers here, my thumb and my index finger, to actually control that pipette. You can do it like this, but this gives you a lot more control. Again, make sure it's seated firmly, and then you're going to expel all of the air out. So to do that, I'm just going to squeeze it. I don't have to grip it all like this to get it all out. Again, I just need to get most of that air out. So solid grip on it, squeeze the air out. You need to do that before you go down in the liquid you want to transfer. So once I have the air squeezed out, I'm going to hold it like that with all the air squeezed out. I'm going to put the tip down below the liquid and whatever liquid I want to transfer, and I'm going to slowly release that bulb until it gets to the volume that I want. In this case, I'm going to start with 1 milliliter, and then I'm going to expel it into my tube by slowly squeezing it again. If you squeeze it too fast, it's just going to shoot out like a squirt gun and spray everywhere. So I said I wanted 1.5 mils. So I have to go back and get more. So I'm going to keep it firmly in my hand, squeeze it again, go down below the top of the liquid, release it, and I'm going to draw it up to the 0.5 mil mark. So I already added 1 mil. 1 milliliter to my tube. I'm going to now add half a milliliter to my tube. And you'll notice it fills it all the way to the top. So how did I know I had 1 mil and how did I know I had half a mil? On the side of this, it has the volumes. So you see all of these lines coming up through here. There's one, bear with me, I've got one. And here, there's one. Let's see where the best place is. 1 mil is all the way up here. And if you look at that closely, you'll see that it says 1 milliliter. Down here, it says 0.5 mil. So the lines in between are the other gradations in between. So you have 1 mil, you have 0.75 mils, you have half a mil, 0.25 mils. Again, the ones you're really wanting to look for are actually labeled on here, the half mil and the 1 mil on that transfer pipette. Likewise, on your tube, let's go ahead and turn this back this way. On your tube, it actually has some markings also. I don't know if that's going to show up on the video, but definitely take a look at that. When you get to the lab, you'll see it says half mil, 1 mil, and 1.5 mil. And a lot of times we call these 1.5 mil tubes or 1.5 tubes. Again, that's the volume that they hold. But again, these are your microcentrifuge tubes as it refers to them in the handout. So I just did the one, I just did the water. You'll do the same thing for your protein, your carbohydrate, your lipid, and your vitamin C. So again, you'll transfer these into the corresponding tubes on your in your rack. So again, the same thing here, hold it firmly, depress on all the air, release and draw it up till you get to 1 mil, put that in your tube, go back in here, squeeze all the air out, go down below the liquid, release it up to where it's half a mil, put it in your tube, and then when you're finished, you should have a nice full test tube. So again, that's the transfer pipette. So in the quantitative part, we're going to use these other pipettes. I'll talk about them later. But right now, you're going to use the transfer pipettes for this qualitative analysis. So once you have all 5 of your tubes full, water, protein, starch, lipid, vitamin C, you're going to add the rest of these 15 tubes to your rack. And they will fit. Sometimes you have to turn the lids around a little bit so they'll fit, but they will all fit in there. So now you've got 20 tubes in there, 19 and 20. So there's 20 tubes there. Now what you need to do is transfer down each set here and distribute this 1.5 mils evenly into these 3 tubes. So again, if you have 1.5 mils here and you want to divide that into 3 tubes, you're going to take half a mil and go into here, and then you're going to take half a mil and go into the second tube, and half a mil and go into the third tube. So you want to make sure you keep your transfer pipettes separate. I'll turn this back around so I can work with 2 hands. So your transfer pipettes, you want to open them up, and it's a good idea to label them. So we'll have some Sharpies available. This is one of the hardest parts here, is getting the packaging opening with gloves on. There we go. You just got to pull it apart up at the top, open it up, and you have a nice fresh transfer pipette. Now I like to go ahead and label them. Other things I've seen students do is they'll label some paper towels and set them in the right place on the paper towel. You can do that, but if you accidentally hit the paper towels, you've mixed up your transfer pipettes. I recommend just writing on the side of the transfer pipette, just like we have with the stock tubes. Again, like I said, what you need to do now is transfer half a mil into this tube, and then another half a mil into the next tube down, and half a mil into that final tube. Again, each time I'm drawing up the liquid into the transfer pipette and then dispensing it into the corresponding test tubes. So again, this was my stock that originally had 1.5. Now I've got half, and half a mil of water. I'm gonna do the same exact thing except with a different pipette. Again, I don't want to mix my water and my protein. I don't want to mix my starch and my protein, and so on and so forth. So that's why you have multiple transfer pipettes. So you'll open up another transfer pipette. Let's say I just opened this one, and then I'll go to the protein and I'll do the same thing. I'll draw up the protein and transfer into the first tube, go back, draw up from the protein stock tube, put it in the second tube there, draw up from the protein stock tube, and go to the third tube. Okay, so once you have all of these tubes filled up, your stock should be mostly empty. So all these tubes in row 2 should be mostly empty, because if you had 1.5 mils and then you took 3 times 0.5 mils, you should be almost empty. So, and with each of these having 0.5 mil in them now. So now what we're going to do is we're going to use these indicator solutions and put into each of those tubes we just set up. The different rows are going to have different indicator solutions. So these are different molecules. So we know that different molecules react differently to different indicator solutions. And sometimes that's useful if you have like an unknown liquid and you want to know, okay, well, what's in this? Is it a protein? Is it a lipid? Is it a vitamin? Is it a starch? It's useful to have these indicator liquids. Sometimes they can give you a quantitative analysis. So if you want to know, well, how much protein is there in this sample? How much protein is in this biological sample? Sometimes you can use these indicator solutions to do that, and we're going to do that with the quantitative analysis. We're going to replicate that, but for today, with the qualitative analysis, again, we're not getting exact numbers. We're just going to look at it, characterize the color changes. So to do that, we're going to add different indicator solutions to these different molecules. Again, you have test tubes with 5 different molecules going this way. So what you're going to do is you're going to add different indicator solutions going this way now, so that you can see with each of the different indicators what happens to those molecules. Do you see a color change? Because again, as I said, we have different indicators for different molecules. So your setup is going to be like this right here. Again, you've got your stocks up in row 2 that should be mostly empty, and then you've got your molecules into your test tubes in rows 3, 4, and 5. So those indicator solutions you see there are what you're going to add. So if you notice, it says iodine, Sudan 3, and then berberite plus copper sulfate. Notice that row 5 gets two drops. So it gets 1 drop of this first indicator solution and 1 drop of that second indicator solution. So that says it right here in bold too. Row 5 gets both. So let's go over here and I'll show you what I'm talking about. So at a separate location in the lab, you're going to find the indicator solutions. Again, the setup might be a little different depending on what day you're in or which lab you're in. You have these 4 indicator solutions. They're going to go into 3 rows. So this one here, iodine, is going to go in row 2. Sudan 3 is going to go in row 3, and then the final row you're going to put both of these. So I think it's row 3, row 4, row 5, actually, if you're following along. I said row 2, 3, and 4, but it's actually the final 3 rows. So row 3, row 4, and row 5. So here, here, and here. So again, in that first row, you're going to put iodine. If you notice, our iodine sometimes has a dropper bottle. Again, it's actually got a little pipette inside of it that works just like these transfer pipettes. Again, you want to hold it firmly, and same thing, I like to hold it like this. You're going to want to pull it up out and release all the air out. It might have some solution in it, but what I recommend doing is releasing out any liquid or any solution or any air that's in it, and then going back down in, releasing the dropper bulb, and then you just need to put 1 drop in. So 1 drop there, 1 there, 1 there, 1 there, 1 there, and so forth. And obviously I'm not dropping any in, but you will. And just 1 drop. Each one gets 1 drop. Same with the Sudan. Again, the Sudan, you're going to use the transfer pipette. So same thing here. Squeeze it out, draw some up in, and here I'll actually put some drops in. So then this is going to go in this row. So drop, 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 drop. And you want to get 1 drop in each one. I think one of those I had 2 drops, but you're going to go slow. You're not trying to do a 12-minute YouTube video. And then in this last row, you're going to actually put copper sulfate. So you'll put copper sulfate in this one, this one, this one, this one, and this one. Sorry, this one, each one across there. And then you'll do the this last reagent here, this berberite solution. Now you'll notice in this case it actually has this dropper bottle here that I can actually use to drop. I don't have to use a transfer pipette. I can just put the drops in like that. Again, 1 drop from that dropper bottle into each of those tubes. And then you're going to take it back to your bench, you're going to mix them up a little bit, and you're going to look for color changes, and then you're going to record your observations in the table on the answer sheet. Again, you should see color changes. You should see different color changes depending on the indicator you use and the molecule that you're adding it to. So as always, if you have questions, that's what your instructor is there to help you with, so don't be afraid to ask questions. And I'll see you in the next video on the quantitative analysis.